So this is about the Web MIDI API. I am Jeremy Forsythe, Director of Software Engineering at SenSource. We sell people counting sensors. This is Capitol Visitor Center. This is a large grocery chain. We've released 3 apps in the last 2 years. I've been writing code for 34 years now, from BASIC and Pascal, now TypeScript. I do a lot of tooling, DevOps, and stuff now. I've been doing JavaScript for a long time. This was my website when I was a freshman in high school. You can't read it very well, but click here to look at today.mid, the old MIDI files. Yeah, this is from 1997. So, oh man, it's messed up. All right, what is MIDI? Musical Instrument Digital Interface. It's just a technical standard describing a communications protocol, digital interface, and electrical connectors. So in 1977, we got our first microprocessor sequencer, the Roland MC8. Ikutaro Takahashi is the started Roland. Dave Smith worked for Sequential Circuits. And then we had Oberheim Electronics. Tom Oberheim made the first instruments that talk to each other over a custom protocol. These guys got together and decided we needed a standard. So Dave Smith and Chet Wood of Sequential Circuits created the MIDI standard in 1981. It was standardized in 83. It is owned by the MIDI Manufacturers Association. And 2.0 just got introduced last year. It's actually going to have content negotiation, and it's going to talk JSON. So it'll be interesting to see what happens there. So the first devices that had MIDI were the Jupiter 6 in 82. That's as old as me. The TR-909 famous drum machine, if you're into music, and the MSQ 700. First computer that supported it was the NEC PC-88 in 82. Those MIDI song files, like on my website, were standardized in 91, and we got USB compatible MIDI in 99. Basically, all music you hear today went through at least one MIDI interface. Protocol is old, older than Ethernet, HTTP, SSH. So what is it? It's just a serial event-based messaging protocol. This is what a file would look like. It doesn't transmit audio signals. It's just events that cause the receiving device to perform an action like playing a sound. It's just numeric descriptions of an action, pressing a button, turning knobs, things like that. The original standard was 16 channels per device. There are 256 virtual channels on a USB device. And it's just designed to carry messages like notation, pitch, things like that. General MIDI, 128 notes, 10 octaves. If you've ever played a keyboard, you'll recognize these as the first 4 instruments on it. This is the MIDI standard. So what does the message look like? It's 3 bytes. The first one is the command. So a 9-0 is a note on. The second is the key, and the third one is the velocity, or how hard you press it. So obviously this is meant for music, but you can send anything over. It's just a protocol. So you get a command and data, and we can interpret that to do whatever we want. Web MIDI API is a working draft. It's not a standard yet. This is the address you can go to. It defines a means to enumerate, manipulate, and access MIDI devices. In other words, it's just an API for MIDI protocol. Can you use it? Yes. It's in Chromium browsers. If you install the JZZ package, you can use it in any browser and in Node. Note, it is only available in secure contexts, so you can't use it in iframe or in HTTP. So it's a very simple API. You do a navigator request MIDI access, you get your MIDI access, or it fails. And this is what the object looks like. You have an input and an output on there. They're maps, so if you call .values on it, if you're familiar with JavaScript, it returns an iterator. For the purposes of these demos, you'll just see .next.value, that gets the first one. And then we can log out what that input looks like. So this is the Launchpad Mini here. You can see you get an ID. That's important if you're using multiple devices, so you can find it by the ID, and that is an input. This is what a message looks like. So you assign a function to the onMIDI message property, and then it gets these messages here. The important part of that is the data property, and this is what you'll get. Those 3 bytes. So you get a command. This is a note on 090, note number 0, and then your velocity. Some devices, instead of the 80 for note off, send a velocity of 0, like this one does. So this is the Novation Launchpad Mini, created for audio, Ableton, Fruity Loops, that kind of stuff. 8x8 RGB backlit pads and 16 RG backlit buttons. As far as MIDI is concerned, there's not much difference between those. The top buttons, let me make that smaller. Maybe. There. The top buttons give the command B0. The buttons are numbered 6A to 6F. The pad area give the command 90, and then they all have numbers based on the second digit. So let's look at some demos. Is that readable?
One more.
One more. So when we start, we're going to request MIDI access, set a listener for the data, and then call this Get Launchpad MIDI button. Here we're just going to figure out whether it's one of the top buttons or one of the other buttons, figure out the velocity, whether it's 0 or 127. And then we're going to log that out. Let's see what buttons I'm pressing here. That's your pad, your top buttons, and side buttons. It's a fairly simple protocol. So this is also a MIDI output device. You can set the colors and the brightness of the pads with MIDI commands. It's the same thing. You send a command, note, and velocity. For this device, it's easy because they publish all this stuff. So the command's the same as the input. The note number is the same as the input. And then you do some bit math to tell it whether it's green or red. This does have a buffer to blink, but we're not going to do that now. So... all right, for the output, basically we have the same stuff to tell which command we're going to use. Just made an array of buttons and figure out with the X, Y, which button we're talking to. I have some two-dimensional arrays here to say whether the light is on or off, to make some letters. Some color values to tell how to make red, green, amber, yellow. And then a function here to do that bit math. Just a couple functions to send these commands, basically. We're going to make an array of these commands and then send them over MIDI. I don't know why you guys can see this, but it's going to say code Youngstown.
Nice.
Okay, the next one. All right, this one's slightly more complicated. We'll have this MIDI ES6 module for the rest of the time. that gets inputs and outputs. It can do bidirectional stuff. It's the same thing you've seen before, though. Request MIDI access, you get your inputs and outputs. This is using P5.js. I don't know if you guys are familiar with that. It calls the setup function when it starts to initialize stuff, and then it calls draw repeatedly. In this case, we're going to set a frame rate of 1 frame per second, and that's just going to call draw. We're going to handle, this one doesn't have any MIDI buttons. And then it's just Conway's Game of Life. We're going to randomize the board, calculate the next generation, and show it on there. Yeah. All right, another input demo. This is the MIDI API along with the Web Audio API. So again, we're going to handle a button press. It's going to listen to all these buttons and call a note on or a note off when we press or leave go of it. If you're not familiar with the Web Audio API, you can do a lot of cool audio stuff in the browser now. You create an audio context. We're going to create an oscillator. Based on the note number, I have a function to get the frequency from that to play. Note on is going to set the frequency on the oscillator and tell it to play now. And then note off is going to suspend it. There's a lot of other cool stuff you can do, pitches, envelope, all the stuff that you would do with audio equipment, you can do in the browser now. Pretty simple. Another cool thing you can do is control visualizations. So, this uses Three.js, three-dimensional graphics in the browser. All right, so we have similar audio. We're actually going to use a waveform and analyze the audio. You have to create a gain, create an analyzer and connect that, setting the FFT to 512. The waveform gets a uint8 array of the frequency bins of the audio. And then we start a waveform analysis, request an animation frame so this keeps going, and then get the byte frequency data from that. Visuals, I won't go through all this, but buttons here will increase the X and Y rotation on this, and then there's just a bunch of visualization code. All this code will be available on GitHub if you want to check it out. All right, now we'll do some input and output. This is P5.js and a snake game. So snakes use the same thing, P5.js. We're going to call setup, get our MIDI input and output, call a draw on that, and handle button presses. Snake itself is a simple game. There's a snake class. I don't do a lot of classes, but games are good for those. New food is food eaten, direction change, fairly simple game. A couple hundred lines of code. It's gonna fail. All right. So it's playing on there and here. I don't know if I can do well on this, but
That's awesome.
so that's fun.
Keep going.
Hey, there we go. So it is still playing on here. And control it with the accelerometer of this if you're good enough, and I'm not. Or buttons. So multiple MIDI devices at the same time. All right, Arduino MIDI controller. It's just 4 buttons, a simple sketch. It does take a custom firmware to talk MIDI over the USB. The firmware is called Micronaut. It's open source. You can go grab it and build it. You put in whatever ID you want, name of the device. If you're familiar with Arduino, in order to boot it to put sketches on it, you have to connect pins 4 and 6 here when you start it up, and then you can put a sketch on it. Then when you reboot it, it's in MIDI mode. 3D printed the case. The buttons didn't fit in it, so that's why they're on a breadboard. I'm upside down. Wrong way. Okay. It's fairly simple. The sketch is like, it really is. The sketch is like 30 lines of code. You know, it's pretty simple. So, all right. My soldering skills aren't very good, so we just leave it like this. I did desolder these from an old drone, and that was kind of messy. So. All right. And then one more demo, robot controller. So this is a Sphero Bolt. I don't know if you guys have ever seen one. It's a coding robot for kids. I have it for my daughter, teach her JavaScript. So they used to have an SDK. It's archived. It didn't support the Bolt, but someone, of course, on NPM made a package. You can pair and communicate with it. So let's try it out.
Would you get 8 out of 9?
Close enough. Hey, it's rolling. It woke up. No, it's not going to move. All right. Well, it moved. Hey. There we go. So what's it good for? AV applications in the browser, digital audio workstations, video editors, live video performance, whatever you can think of. Like I said, Stream Deck. Instead of paying $150 to $300 for a Stream Deck, you can pick this up for $50. Has a lot more buttons on it. Accessibility for web apps. If people have a hard time typing, you can give them MIDI controllers, and they can use a computer and you know, access it that way. Custom controllers if you want to make musical instruments in whatever shape, the CNC, 3D printer, or whatever. Playing with robot balls if you can get it to work. Sending sensor data over MIDI. It's a very small format, small protocol. So, and it's early stages. So anything you can think of, you can do. So, that's it. The slides will be up on my GitHub along with the code if you guys want to play with any of it.
VSTs and all that?
Yeah.
All good?
I think so.
Okay.
James, take it away.
All right. Thank you. Hi, everyone. My name is James Kleeh. I'm the product development lead for the Micronaut framework. We actually just had our third birthday, if you want to call it that, for the framework recently. Right? Since we had our first release, right? So since 1.0. And earlier last month or 2 months ago, we released Micronaut 3.0. So we're following, semantic versioning, so breaking changes. So Micronaut is it's a general purpose framework for the JVM. So its sort of focus is microservices, but you can do a whole lot more with it, right? So what you're looking at right here is a thing we have called Micronaut Launch, and you can just generate applications just through the website. You just go to launch.micronaut.io, and you can you have all these different options to choose from. But one I just want to call your attention to is these different sort of application types that we support, right? So we have like the standard web application, and you can create command line applications. We have a great integration with a tool called Pico CLI to create command line apps with Micronaut, and functional applications for serverless. So Lambda, Google Cloud Run, Google Cloud Function. There's ones for Azure. So we have integrations with all those cloud providers. And then you can also just have a gRPC if you're not familiar with that. That's like the Google protobuf communication layer, so not using HTTP. So we have a cool integration with gRPC. And then also just a straight message-driven application. So if you just are listening to and sending messages like through Kafka or RabbitMQ, or there's like 500 of them out there, and you're not doing traditional web communication, you can create an application that just does that. And so in addition to the actual application, to this web application to create an apps, we also have a CLI, which is called MN, which you can install like for Linux-based users. There's a tool called SDKman, which is pretty nice. You should check it out. But you can install SDK install Micronaut, and it will get you the CLI. And so, but before I start, I just want to kind of ask a question of the group. Who here thinks that, who has a perception that Java is slow when it comes to startup time specifically?
Your perception that Java is big.
Big?
You know what I mean? Like,
Yeah.
you know.
Does anybody have the perception that Java is fast on startup time?
I write JavaScript, so
Right.
everything's faster
No, yeah, not even close. Okay. Well, so hopefully by the end of this, you have an opinion one way or the other, right? You can base what I show you here based off your own experience, and you can decide. So I'm just going to create a simple application. So we could just use the mn create app command. Can everybody see that? Okay. Yeah. All right. So we'll just we'll say this is our basic app, right? And it defaults to using Java, and Gradle is the build tool. So then I'll just go ahead and open that up. All right. So when you create an application, it generates a README right in the root that contains useful links and information to get started using the framework. And you're basically left to get started from there. So the application class is sort of the entry point, right, of when you run the application, and it goes through the application class. But I'm just going to go ahead and create I'm going to create a controller, and we'll just call it, we're going to interact with the GitHub API, right? So we'll say this is the GitHub controller. And to make it a controller, you just annotate it with controller. And so here we're gonna take some request. We'll say like at get. So we want to get the stargazers, like how many stars a repository has, right? So we can just say like stars, and it will return the best practice here. I'll show you the best practice. You don't have to do this. Is to return a publisher when you're talking about controller actions, because Micronaut uses Netty for its network layer, and Netty is a non-blocking network framework, sort of, right? And so by using a publisher, you don't block the, because it's based off of an event loop, similar to like how Node works, right? So we're just going to return a publisher of string. All right, and we need to take in what repository we want to talk about. So we can pass that in as like a query value, or you could do any sort of thing. But I'm going to take it in as part of the URL here. So you can just define a with that special syntax using the curly braces in the URL. You can specify like a variable that you want it to bind to. All right, and so now we're going to write some an HTTP client to get this data. And Micronaut is everything is done at compile time, right? And that allows us to do a lot of interesting things. And I'll show you one of those things. So I created an interface called a GitHub client. You can just annotate this with that client and pass in the base URL that you're interested in. Right? And then you can create methods on here to then do the request to their API. So we can say at get, and it's slash repos, and then the repo URL. Right? So we're going to make a get request there. Whoops. I'm not used to this keyboard, so you'll have to excuse me. So, and here we're going to return a class that I haven't created yet, so we'll just call it GitHub repo. And we'll create a publisher of it, right? Publisher of GitHub repo, and I'm using this so I don't block, so no blocking operations. And we'll just call this get repo. And we'll take in the repo slug there. All right, so I just have an interface. And now I'll go ahead and create that class called GitHub repo. And so this is a class that basically the JSON is gonna come back from GitHub, and it's gonna be bound to this class, right? That's gonna happen automatically. There's a couple of things that we need to do to sort of make that easy. And I'll show you that. So one of the things that we need to do is annotate this with something. It's a Micronaut annotation called introspected. This allows instantiation and reading of writing to the class without the use of reflection at runtime. So we write code at compile time to interact with this class. So that way we don't need to use any sort, because reflection is slow in Java. It's a slow way of going about things. And then we're just going to have some stargazers variable. Oops. And I'm just going to go ahead and generate a getter and setter for that. And we'll annotate this with the property that we want it to bind to from the JSON coming from GitHub. So we're using the JSON property, and I'm pretty sure it's called stargazers count, right? And I think that's that. So then in here, so we have our client is defined, and Micronaut uses a dependency injection system. So there's a concept of scopes, right? So we can inject that client just by saying @inject GitHub client, right? And then we can just use it. So we can say we can return GitHub client .get repo, and then we can do some interesting things to convert that to some other response other than just the stars, or we can create some message. You can use any sort of reactive library that you want in this case. But we have some baked in sort of easy to use APIs to do that. So in here, so I'm just going to return a message. I'm going to say repo has repo info bucket stargazers stars. Right. So I hope that will work. So we can just run it and see. So I'm just going to go and run the application. And I have to change it to use Java 11. Let's try it again. So because Micronaut does everything at compile time, you'll find that it's much faster than traditional frameworks, right? So the application itself started up here in 760 milliseconds, and now we should be able to send a request at it. So let's just give it a try. So it's going to be repo, in our case it's controller is /stars, and we'll use Micronaut Core as an example here, and let's do a -I and we'll see what happened. Okay. Oh yeah, so I forgot. There's this weird thing with GitHub, and that they require you to have a user agent header on their requests. So I'm going to add a user agent header. And we'll just say Micronaut demo. Okay, and we'll restart the app. And let's try that again. Okay, there you go. Micronaut projects, Micronaut Core has 5,078 stars, right? So just to clarify what happened there, we sent a request to our local controller, to our local application, which then submitted a request to GitHub, and then got the data back, converted it to our custom class, and we converted that data down, sent down to us, right? So pretty easy to get started, you know, with HTTP-based stuff. There's really, you know, there's not much to it. Pretty easy to use, I think. You agree? Pretty easy to use.
Sure seems that way.
Yeah.
Does it tell you how long that request took?
I'm pretty sure curl would if I knew what the option to pass it to to say that was.
See how fast Java really is.
Yeah. So. Yeah, I mean,
At that point, it's going to depend on the internet connection speed.
Well, we've got 200 megabits down, so I don't think that'll be an issue.
Yeah.
You're dependent on I/O at this point. So the I is based on
It's not the bandwidth.
the World Wide Web. It's not going to give you the Java.
Right. So, yeah, so Java traditionally, like as far as throughput and requests a second, is historically almost always, you know, one of the best. And we run benchmarks with this all the time, and I think you would be pleased. I don't have any benchmarks prepared to do that, but yeah, and and so one of the things that Micronaut is really that we really focus on too is testing, right? And one of the benefits of starting up fast, right, starting up in 700 milliseconds versus 30 seconds or 60 seconds, is that you can write all integration tests. You don't really need to write unit tests when you're using Micronaut, because if you used other frameworks that are slow to start, you would find that those people write a lot more unit tests, because otherwise their whole test suite would take 25 years to complete, right? Which is obviously not good. So I can actually test this using an integration test pretty easily. So we have an annotation called Micronaut test, which you can put on a test class. And then this test is also a bean, so you can inject things into it, right? And I can inject a client to call the local application, right? And I'll just say HTTP client. All right, and I don't use JUnit that often, so we can say HTTP client dot to blocking, because we don't care about blocking in a test scenario, and we can retrieve slash stars slash Micronaut projects slash Micronaut core, and assign that to a variable. So message. All right, and there's actually one thing I want to change here before we do that. So this will by default send back. So if you saw in the response, it was actually like an array, right? Because we assume if you're sending back JSON, if it's a publisher that's coming back, you're going to emit multiple items. It's likely going to be an array. But in this case, I'm just going to say a single equals true. So then we won't get an array anymore. And then in our test, I can say assertions dot assert true, and I could say message dot contains this this sort of message here. Right? So I mean the stars might be different, and I'll show you how we're going to handle that here in a second. So this is not a good test, right? Because the stars will change, and then your test will fail, and then you will have failed, right?
Just keep updating.
Right, yeah. So let's just run this test and we'll see if it passes. It did. So the golden rule is to never trust a test that passes the first time you run it. So let's just make it fail first, just to make sure. Okay, so we're good. All right, so but this isn't really ideal, right? Because you don't want to call the GitHub API for your tests, because you'll start running into rate limits, and that would be a big problem, right? Well, because your client is an interface, it's pretty easy to just create a mock implementation of that for your test, and you can just do so by creating a method in your test, and then that this replacement will be specific to this test, so it won't apply to other tests, right? So we can say mock client as the method name, and then you annotate this with mockbean, GitHub client. And then here we can create, we can just say return new GitHub client, and then just return publishers.chest, and we'll create a new GitHub repo manually. We'll say repo info set stars 200, for example. All right. And then this is telling me that I don't need to actually do this part. I can just do that. So we have a mock client now, so we're no longer going to be calling GitHub. So let's just run the test, and then we'll see. So I'm expecting it to fail because it should be 200. And if you look, it just says expected true was false. There's a testing framework for that's based on Groovy called Spock that is a lot nicer. So I'll just change that to 200, and then we'll run it and we'll see. Right? So now we have a test that's testing our controller in an integration test, right? This is an integration test. We actually spun up a real server. We sent a real HTTP request over the local network, and got back a response and asserted what it is, right? So we only mocked the third-party stuff, which is good to do. All right. I'm pretty close on time, so I'll show you one last thing. So the application starts, I showed you before, in 676 milliseconds, 700 milliseconds about, we'll say. But we can actually start a lot faster. There's a tool that's being developed by Oracle right now. It's called GraalVM. Has anybody heard of that? GraalVM? Heard of it? So because Micronaut does it, GraalVM is creates native images for Java libraries or Java code. So as you know, how Java works is you compile to a sort of middle ground, right, called Java bytecode, and then when the thing actually gets executed, it gets compiled to the native code at that time, right? It's called, the just-in-time compiling, right? But GraalVM is a way to go directly from your Java code to native code. And as a result, you no longer have all the overhead of the JVM. Essentially, you're just running native code, right? So I'm going to build a native image, and let me make sure I'm using the right. Let's go use Java. So I'm going to build a native image. So we can just say native Gradle native image, and this takes like about a minute. But it's definitely dependent on hardware. Building native images is not like it's resource intensive. It uses up a lot of memory. It's sort of a heavy process, but the end result is something that's pretty cool. And I think I forgot to add something to make it work, but we'll see. But Micronaut supports packaging this like any other, you can package it as like a jar and ship it off to, whatever. You can package it in a Docker container. Our build tooling supports, basically all the things that you would want to do. Any questions while we wait? Yeah. Yep. Yeah.
The package builder on the website gives me old school jQuery UI vibes when you used to have to go build that out, which is scary but also awesome at the same time. But I'm kind of curious, what do you, usually when you have a framework in a language, it's very specific to something, to CLI, to web, but this seems to be everything. What do you lean towards when you think of Micronaut? Like, what do you think its best use cases are?
I mean, so our definite focus is microservices. Right, that's where most of our effort.
Or like server-based, like on like web kind of.
Yeah. But microservices, whether that be messaging-based applications or web-based applications, they both. It's really just, is there a server there or not? And that's really other than that, it's the same. You can use messaging stuff in a web context, right? It's the example here of the client. If you want to use like Kafka, you can just say at Kafka client instead of at client, and now you're publishing Kafka messages just based off of an interface. So we have integrations with a whole bunch of things that are very easy to use. But generally microservices and whatever that means to you. All right, so I think we're done here. So let's give this a try. So it's under a native image application, so I'm just going to run it, and you'll see we started in 22 milliseconds, our application. Same application now starts in 22 milliseconds, and I think it's not going to work right, but we'll try it anyways, because I forgot something.
That's an impressive startup time for horizontal scaling microservices.
I think so. Yeah. Okay. Yeah. So I was expecting this. Because we're using Jackson in this case to do the JSON parsing, we have to annotate this with effective access, and then that will do all the configuration for GraalVM to get it to work. Right. So if I were to rebuild it, it would work. I promise. But yeah. So 22 milliseconds compared from 700 when you're talking about in a serverless architecture. It's super critical, right? Even though 700 is fast, right? But starting like a Node app is, immediately for the most part. And so Java has always struggled in that area. So with Micronaut, it's really easy to use GraalVM, and GraalVM is awesome. You can create native images and start your apps, instantaneously.
And you can create the native for the Linux?
Yeah. You can create native images for other things by using the Docker-based approach. So it will spin up a Docker container for that architecture and then build a native image in that.
So when you first started this thing up and did the builder online and it gave you a package, where does that go? Like when you, so it's obviously not, is it within your project directory or is it almost like a package that you're importing like a library? You know what I mean? Because it's not, you're not just spitting out like a framework with code. A lot of times, like I'm thinking in Python land and Django, you go start Django and it gives you all these files that you plug your own stuff into. But you kind of have a clean slate to start. So
Yeah.
You basically have a library that's built and you're just importing it.
Exactly. Yeah. So so the build.gradle file is like the build setup, and if you look in here, you'll see we have there's some dependencies in there. There's not very many because we handle some of them for you, right? So you can say the runtime is Netty, right? If you wanted to use like Tomcat, you just change that to Tomcat, and now you're running on Tomcat. If you want to use JUnit, you just say JUnit 5 here. If you want to use Spock, you just put Spock here, and now you're running Spock, right? So, so we have a build plugin that configures some of that for you, and then for the things that we don't configure for you, there's little dependencies listed here that brings in the stuff necessary to get this all running.
So when you configured it a command line. If you go through the website, what does it give you?
So it gives you an application very similar to this, but instead of it gives you like an example command
Okay.
that you start with. I can show you. It's pretty. So I can say mn create CLI app, right? And so it's the same thing, except you have a command here, which is using that Pico CLI as its basis, and then you just get a run, so all your stuff goes there, and you can add in options and parameters and whatever, and you're just off to the races. So.
Unfortunately, most of the time Java comes up in my life is like a student from YSU just survived a Java class, like either object-oriented or I guess they're teaching a web app class using applets now. And they come up to me and they're like, I want to do a project using Java. And I'll be like, yeah, basically. But Micronaut seems like a perfectly sane way to do a project. Like it covers a lot of bases, like a web app project or a command line project. But I don't know if, you know, given the web interface that just selects to select stuff, that they'd be able to get very far. Do you think that docs would be efficient to throw a student on, or do you have like some additional resources?
We have something called guides, which would probably be the thing to do. Our docs are more of like a reference documentation. That's not really what it's for. But if you just go to guides.micronaut.io, we have a ton of guides on a whole host of subjects, and depending on what you want to do, there's a bunch out there. Yeah.
That's awesome. That's perfect. Now I have an answer for those people that aren't from Scott.
Yeah. So, you know, if you want to deploy an app to Google App Engine, just click on that, and there you go.
And you mentioned the easy integration with like Kafka because you guys developed like a plugin for Micronauts.
Yeah.
Like Kafka or RouteMQ or whatever it is.
Yeah.
Have you guys done any integrations with like AWS, SQS, different things out there to leverage those type of systems for messaging instead?
Is SQS tied with?
SNS and SQS.
I'm not sure. I think so, but I'm not positive.
Okay. I was just curious. I can look it up.
Yeah, there's we have something that is it SQS? Yeah, I'm not sure. I'll look it up. I'll send it to you if I find it. But yeah, we have integration with lots of things. But you know, as you know, there's like 5 billion tools in every cloud provider, so it's impossible to So it's we've only been out for 3 years, so something like Spring is going to have more integrations with other things, but I think we've covered like the 90% of things that you would want to use.
So I know you work for OCI and work on Micronaut. Is Micronaut OCI's, or are there multiple companies that are contributing to the project, or individuals?
That was about to be my question too. I'm wondering the business end of it.
Yeah, so Object Computing owns the trademark for the framework, right? So we have control of it. However, there is a Micronaut Foundation, which companies can sponsor. We do have sponsors, and Oracle is also a major contributor to the framework as well. So that's really very advantageous for us because GraalVM is based on Oracle. We can have like joint builds to make sure that everything works, and so if you're talking about GraalVM, which I think is the future of the JVM, we're sort of best poised to take advantage of that.
So is this fully open source or is
Yeah.
it licensing? Okay.
Yeah, Apache 2. Anything else? Okay. Thank you.